Okay, let's take a look at some more examples here. We're going to move on to situations where we add events, right? Have multiple events occur, and we call these and or situations. Mathematically, it's called a union, right? What's the probability of A or B happening, right? In this case, it's one or the other, or both, versus the probability of A and B occurring, which is both have to occur, right? The chances of both occurring. And so looking at this here, back to the simple dice event, right? 6 numbers. What's the probability of A or B, which is rolling a number greater than or equal to 4, or rolling an odd number? And so you can see in this situation, these are all the numbers greater than or equal to 4. These are all the odd numbers. And so the probability of A or B happens, right, is the probability that one or other or both occur. And so in this case, there are 5 potential outcomes, right? These are all odd. These are greater than 4. And the only one that doesn't fit that is a 2. And so you can see that it's 5, 6, right? Because the probability of getting a 2 is the only one that doesn't meet that. And so that's another way to think about it. If you want to look at the complement event, you can also, we could have done 1 minus 1, 6, because the probability of getting a 2, sorry for that writing, the probability of getting a 2 is 1 out of 6. So again, that form of complementary thinking sometimes works out better. But I want to show you that Venn diagram just so you can get a visual of this or versus in the and situation. The probability of A and B, right? There's A and B. There's only one event. That's not a 1/3. It's 1, 3, 5 because it's odd. Sorry about that. This is 5. There's only one outcome, right, with that 1 out of 6. And so again, key words are and or when we kind of start to contextualize and think about how those words interplay with each other, right? And so we continue on. So we're going to play with that. We'll get some more problems we'll do at homework for sure. But another idea connected to this or and is what we call conditional probability, right? And the word given, when we use the word given, we can often interpret this as out of, and we'll see what I mean by that, right? And so in our calculations here, what's the probability that A occurs given, what's the probability of A happening given that B already has occurred? And that's what this given symbol, right, this vertical bar represents. Well, so probability of rolling a number greater than or equal to 4, given we know that the number, right, that it's out of the odd numbers, right? Come back to this odd, given that it is an odd number or that's out of the odd numbers, right? And so this would be 1 out of 3 if you think about it, right? Here are the odd numbers, and what's the probability that it's greater than or equal to 4? Well, there's only one option, 1 out of 3, because there's 3 odd numbers. So this conditional probability is, again, a form of thinking that occurs in statistics and probabilistic situations, where we always have to consider potentially how an outcome is dependent upon another outcome, right? Is there a connection between those, which we end up talking about further again. But it's really this idea I need you to pause and think about what other conditional probabilities could you imagine, right? So here's a quick example here. You can see, draw a Venn diagram based off of the situation, right? There are 8, bring a bicycle. Of the 8, 3 of them brought a bike and a kite. So that's where this 3 comes from here in the middle. And so then that's where you end up with this other 5, right? Because 5 then only brought a kite only. And so you can see 8 of them brought a kite. You can see 8 brought a bicycle. 3 brought both. 5 brought only those individually. And right out of the total of the 20, then that leaves 7 left over. And so keep that in mind there. So we can calculate these probabilities. What is the probability that a child chosen at random brought both, right, a kite and a bike? That's 3 out of 20. Was the probability that they brought a kite or a bicycle? That's our 13 out of 20. You can see, right, it's that example of they brought 5, 5, and there are 3 here. So that's a total of 13 that brought a kite or a bicycle. And remember, or both will occur in this case, right? So the 3 is considered in there. And so we have that calculation there. Yeah, I'm going to pause there and then we'll do some more examples.